In this lesson, we will go through fundamental chemical laws. Chemistry is mainly concerned with chemical changes. However, before going into those details, we should go over some history and fundamentals of chemistry. Greeks were the first to attempt to explain why chemical changes occur. Then alchemy dominated for 2000 years. Several elements discovered. They also prepared mineral acids. Do you know who was the first chemist? Robert Boyle was the first chemist. He performed quantitative experiments, developed first experimental definition of an element. Now, the three important basic laws in chemistry are law of conservation of mass, which states that mass is neither created nor destroyed in a chemical reaction, and this is what we apply while balancing equation. The total mass on both sides of the equation should be same after proper balancing. So when you add the mass of sulfur with the mass of iron, 32 plus 56, it's equal 88. So this is 88 on left side of the reactants here and 88 on the product side here. This was the contribution by Lavoisier, who introduced the value of accurate measurement in chemistry. Then Joseph Proust introduced law of definite proportion. As the name indicates, this law means that a given compound always contains the same proportion of elements by mass. Say for example, water always contains 2 parts of hydrogen and 1 part of oxygen. Proust's discovery stimulates John Dalton, an English school teacher who had some disability like color blindness and he was not articulate. He contributed the law of multiple proportion, which states that when two elements form a series of compounds, the ratio of the masses of the second element that combine with 1 gram of the first element can always be reduced to small whole numbers. For example, hydrogen combines to oxygen to form two compounds. It can form water and it can form hydrogen peroxide. The mass of oxygen that combine with the 1 gram of hydrogen. Here it shows 2 grams. So 2 grams of hydrogen and 16 grams of oxygen. 2 grams of hydrogen and 32 grams of oxygen. So if it is 1 gram, how many grams of oxygen will combine? And if it is 1 gram of hydrogen, how many grams of oxygen will combine? When you calculate that one, you can see 16 to 32, it will be 1 to 2 ratio. That is what law of multiple proportion explains. It will it will always 1 to 2 or any symbol other ratio if different elements are combining. Another example, you can say carbon combines with oxygen to form carbon monoxide, which is CO, and carbon dioxide, which is CO2. You can see again oxygen combines with the 1 gram of oxygen in the ratio 1 to 2. These two examples are 1 to 2. It doesn't mean that it's always 1 to 2. It can be symbol ratio. That is what it means. And now check for understanding. Which of the following is an illustration of the law of constant composition? Water boils at 100 degrees Celsius at 1 atmospheric pressure. B. Water is 11% hydrogen and 89% oxygen by mass. C. Water can be separated into other substances by a chemical process. D. Water and salt have different boiling points. So you have to pick the right answer here. That is for law of constant proportion, which is law of constant or definite proportion or constant composition. Both are the same. So here boiling point they are talking about, that is not the point we learned in law of definite proportion. Here we can see that hydrogen is 11% and oxygen 89%. So water is 11% hydrogen and 89% oxygen by mass. We know that it is the mass and it is not going to be changed. So let's see the other answers. Water can be separated into other substances. This is what decomposition they are talking about. And water and salt have different boiling points. Again, they are talking about the property. So here the right answer will be B. Water is 11% hydrogen and 89% oxygen by mass. That indicates a definite proportion. That's it. So we can practice more questions and move on to the next lesson.